I am Jorge Ortiz, and welcome to BPPD. This week's episode is about testing tables, and that's something that is very easy to do in Go that not everybody uses. So I'm going to try to show you a scenario in which you could do this testing uh, organized in tables, the same test that we did for the previous two videos. But in this case, we are going to have them as just a single test with three subtests. And we will see how to modify the code and pass from one code base in which we have the three tests to the other one with one test and three subtests, which will be easier and shorter. Okay? But before I do that, I want to do something to close the example that I was doing in the last episode about passing back errors. So if you remember, and let me show you this. If you remember from last episode, and otherwise you're going to have an some indication here to load the episode. There was this function that I extracted on the first episode, and I was one of the parts, well, one of the things that this function was doing was that when it got to getting the information from the database, if it didn't get it successfully, then it would exit. And what we did was modifying this function so the exit didn't happen inside of the function, but it actually was bubbled up. It was returned to the caller. So our list function that you have here, this list function, that is the one that we extracted, instead of doing an OS exit one here, it returned an error, and it was its caller the one that was responsible for checking that error and in that case exiting. Even there, I don't think is the right place to put the error, to put the exit. You should do the exit mostly in the main function. But for the purpose of that testing, that was enough. We refactored and we moved that part of the code to the caller, and that was working exactly as the original code. But one thing that we didn't do was to modify the test to take that error into account. We know that if everything goes well, so if there's no error here, what is returned from list should be, sorry about that, should be nil, so no error. That is also the case here, no error. Okay, so what we should try to verify in the test that we already have is that that is the case, that there's no error if everything goes fine. Let's go one by one through all the tests, and let's go to the test file on the right side of the editor, and here this is the first test that we wrote. So here what we're going to have is to take this error into account. So I'm going to, sorry about that. So what we're going to do is, if there's an error returning from there, what I'm going to do is to say, hey, everything went wrong, so error F, and that would be unexpected error when calling list. Okay, and we will print the error so we know if that happens what error is returning from there. Okay, as is that simple as that. In this case, where what we have done is modify the code so it works taking that error into account. Let's run this code. So we're going to run all the tests here and everything passes. Let's go back to here and let's modify the second one. Let me copy this so I don't have to worry about this typing. And here we're going to do the same in the second test. This is when we get a task from the database. So here I'm going to do this instead of just calling the command list. Okay, so far so good. We run this other test and yes, it works too. And in this third case, what we are checking is that there is something going on that is a problem. So here, what we are going to do is something similar, but not exactly, something similar, but not exactly the same as we were having before. So what I'm going to do is to check if there is, we are expecting an error. If there is no error, we're going to complain. So instead of doing if error is nil, is not nil, we are going to complain if the error is nil. So if there was no error, since the scenario that we are testing is that when there is a list error, we're going to print a message. We would like to verify that this error is being returned. Okay, so what I'm going to do is exactly the same as I was doing before. So I'm going to display an error, and this error is going to be unexpected error, lack of error when calling list. Okay, and I'm going to, here I don't need to print anything actually because there's no error to print, so that should be enough. Let me remove the F because we don't need to do any formatting here. So again, we run this and we have checked every error as expected. For the cases where there should be no error, we verify if there's an error and we complain. For the case in which there should be an error, if there's no error, we complain. Okay, so that is for the errors. Now, if you take a look at the three tests, like in the three of them, we prepare some stuff, which is mostly the message that we expect to get. Then the function, we prepare the data that is going to be returned from the database function. And then we execute this. That is very similar in all of them. It was originally was the same, but now that we're checking errors, it's slightly different. For some cases, we are expecting an error. For some cases, we aren't. And finally, what we do is we assert that the message is what we expect. Okay, so that is not only happening in this test method, but also in this one. This test function is doing exactly the same, is preparing some stuff, loading the function with the data, then executing and capturing the error, and finally asserting if the message is the expected one. Same thing happens with the first one. If you go to the first one, you will see the same behavior. So here we will have, again, preparing the things, string, and the database function, invoking and checking the error, and executing an assertion to verify that the output was as expected. Three examples, three tests that do more or less the same. So is it worth to have three tests instead of one? Well, I would say that it isn't. But how do we fix that? How do we have a test that takes care of that? So let me write a fourth one. And the purpose of this obviously is going to get rid of the first one, so of the three first ones. So we're going to have four initially, but at the end, we are going to just have one. Let me put it here at the end. So that should be here before the auxiliary function that we did on the first video to capture the data. And here I'm going to create a new test. And this test is going to call test list. Simpler because here we're going to have subtest for each of the things that we want to do. Okay, so in this test list, what I'm going to do is to have a test table. And I have a snippet here that creates most of the structure. So as you can see here, you have an anonymous function here, an anonymous struct, array of structs. So this is an anonymous struct, and I'm defining an array of these things that there's no need to define the name of this struct. Is anonymous, is only going to be used in this scope. So what I'm going to have here is for each of the tests that I want to perform, I'm going to have an element in this array. And it will have as many fields as we need in order to treat each test differently. So let's copy one of the tests here, and let's see what we are going to need for each one of them. So let me go to the beginning of the function. I'm going to start with the first one, and I'm going to copy everything in the first test. Now I'm going to the method that the function that I have just created, and here notice that it has a loop, and the loop says for each of the elements in the table that it has been defined in just before, I'm going to run a test. I'm going to use the name that is defined in this name field, and I'm going to have a function that is going to do the testing. That's it. So what I'm going to put inside of this function is the content of the original test. So I'm going to have it here. Let me try to center this in the screen so you will see it all together. So this is the loop, and I'm going to have all the code run for each of the tests. But for each one of them, I'm going to try to define what is different and how do I need a variable that is different for each of the tests? And if so, I'm going to put it into the anonymous struct. So, for example, the expected message is something that I'm going to have that is going to be different for each of the tests. So what I'm going to do here is I'm going to take this out of the test. I'm going to move it into one of the instances of the struct, and I am going to obviously define this in the struct, so it knows what is expected. You see? So I am assuming that I'm going to have a different expected message for each of the tests. So what I do is I define an expected message field in the anonymous struct, and for each of the different tests that I'm going to run here, I will have a different value for this field. So that is the first one, the expected message. So I can get rid of this. And the second one is how I prepare the function. The function is loaded with different data based on the purpose of the test. That's why I was talking about dependency injection on the first video. So I'm planning to be able to control the data that is provided by this database, and I do it by defining this function. So how do I solve this here? Well, again, I will create another variable, and let me put it before, and I will tell you later why. That is going to be a database function. Okay, so I'm going to call this dfn, and what this is going to do is going to provide me with a function that is going to be this one. Actually, just for the purpose of simplicity, I'm going to use lfn as I was using in the original one. So what I'm going to have here is define this function that takes that. And in order to be able to have this in every instance of the struct, I'm going to make a field for it here. So the syntax here is without the colon, and as you can see, now you have the two things. You have the expected message, and you have the function that is going to be that is going to load data into the dependency injection. Okay. Okay. So so what else do we have here? Well, let's go into the test. We can get rid of this part here, and the message, the way we obtain the message is going to be exactly the same for all of them. So we're going to use the capture output that we were using before, and we're going to invoke the method that we want to try. But here I'm going to assume that I am not expecting a message. We will solve that later, okay? But let's work in the two cases where we don't expect an error from the list. And in this case, I'm going to get this error here, okay? The only part that is different is to verify that this is the expected message. So how do we do that? Well, first, let me go back to the struct, and here I'm going to see that I have a TT for the test table, and here I'll read this test table, and each of the different instances of the struct is loaded in the TC variable. So what I'm going to do here is invoke it as I'm doing with the name. So I will have here a function where I'm using the tc.lfn, which is the list function that I'm using. And here, what I'm expecting to have is here is a tc expected message. Okay? Because that is the other field that I'm having in this struct. Is it clear? Okay. Finally, I need to have a name that is going to be different for each of the instances that I'm running here. So in this case, it is going to be no tasks, which describes the scenario that I'm testing with this instance of the code. Okay. And let's see if that is correct now. And it says that I should solve something in line 92. Let me go there. Oh, so that shouldn't be an equals, but a colon, because this is what I'm having here. Okay. So that is one instance of a test. That is a subtest. And obviously we have done more work to have the same test that we had in the beginning. Let's run it and let's see that nothing changes. Define expected message. Oh, yeah. Let me see if expected message is undefined. 106. Oh, yeah. So if the message is not the same as I was expecting, okay, now it should run the test. And yes, well, it doesn't make any sense because I'm doing more work to do the same as I was doing in the first test. Yes, but now I can describe another test, and I just have to add the curly braces here, and I will go field by field. So I need a name that is going to be one task. Usually I don't put spaces here because I think it's easier to read in the detail if you run the test with a -v. Then we will use the loading function from the second test. Let's go back there. So not this one, that is the one with the error, but this one here. So let's copy this too, and we're going to fix it when we get there. Okay, so I copy this part, and here what I'm going to do is to arrange this as expected. So I'm going to reorder this, and what I plan to have here is the loading function that every field needs to end with a comma, and there's no constant here part, but what I'm expecting to have here is a colon instead of an equals and a comma at the end. So that is the second test. And if I run this, and now let me run this with a minus v, you will see that I'm running on the left side of the editor, I'm running each of the original tests, okay? And here I'm running the test and each of the subtests, and I have a passing for each of the subtests. So this organization, by just changing the variables that I have here on the right, allows me to have more tests by just describing the new test case. Okay, sounds interesting and powerful. Okay, so let me now do the final one. Let's try to do the one with the error. Okay, so let's copy this and let's try to describe this error, and let's see if we need anything else here or not. Okay, so for example here, what I'm going to have is describe a new test case that I'm going to have in between these two curly braces. The name is going to be DB error, okay, to describe the scenario. And what I'm going to have here is the two things that I have copied from the original test. So what I'm going to put is same thing as I did before. I reorganize this, I remove the equals, I put a comma at the end, and here I remove the const and I use a colon here so I can use this part and with a comma at the end. So if I didn't make any mistake, that is the third scenario. And well, let's run it and let's see what happens. Oh, there's an error. So why is the error? The error is basically saying something went wrong, there was some error. Oh, but this is the case in which there is an error. I should expect an error here. So how do I differentiate that? Well, let me add another field in the struct that is, do we expect an error? And in most, this is going to be a Boolean in the simplest case. And in most cases, I don't need to do anything because I don't expect an error and the default is false. But here, I'm going to say expect an error, and I will say true, and that's it. So now I need to use that in the testing part. So what I would be saying is, if I am not expecting an error and error, where is it? Let me see, because I think I deleted something here. Oh, did I copy it wrong? Oh, yeah, sorry, not there. Here. If, let's run this in a different line. I'm getting the error from here. And what I'm going to do is, if I'm not expecting an error, tc expect error. Sorry, rather, if I'm not expecting an error, but error is not nil, then I will complain that there's an error. Otherwise, if I'm expecting an error, then I don't need to be surprised if there's an error here. So let's try to run this part and see if that works. And that passes, okay? You could do better. I mean, like you could say, if I'm expecting an error and there's no error, I should also complain. That's another thing that we could test, but for the sake of simplicity, I'm not going to do it. The advantage now is that if you go to the beginning of this file and you start selecting from here and go to these three functions and delete them, what you have is something that, in my opinion, is easier to understand, easier to modify. It's just a refactor of the testing code that we created on the first time. So the purpose of this video was to show you that first, you can take errors into account, particularly after what we did on the previous episode of returning errors to the caller. You should take that into account, and we were adding that to the testing infrastructure. And second, and I believe that's more important, you can reorganize your tests into subtests so you can enjoy this structure that we have created here and have tests that are at least simpler to modify and simpler to extend by just adding an instance of the anonymous struct here. This anonymous struct can be anything you need for each of the tests. So in each of these test functions, you can have a very different one, and it would be perfectly fine. It will just use the one that is defined for the scope of this function. So that's something that you can do there and enjoy when you need it. I hope that this has been useful. If you have questions, comments, or suggestions, feel free to make them here in the channel, or send some message to me by Twitter or whatever. Hope to see you around soon, and until next episode. See you.